We are going to study the basic idea of sets. Are you familiar with set? Have you heard the word set before? I know that you are familiar with it. Why? Because we always use the concept of set in everyday experience. Example, we do have set of favorite movies. Avengers, Batman, Iron Man, Fast and Furious, and many other movies. We do have also our favorite set of games. Volleyball, basketball, Dota, ML, and we also have favorite dishes in our house like adobo, tinola, and maybe humba. Each day, we also see set of vehicles in the road, like for example car, bus, jeep, and when we go to school, wherever we go, we do have also set of friends. Example, Matthew, Peter, John. We do have in if you when you were young, I know that you have set of toys in your house. Maybe toy gun, toy car, toy Barbie. Okay, but I want to share to you also that we also use the concept of set in mathematics. Example, we have set of counting numbers. Counting numbers means numbers that don't have decimal point or a negative sign. Like for example, 1, 2, 3. Actually, it starts from 0. Okay? 0, it's included in counting numbers 0, 1, 2, 3, 4, 5, and so on. 1,000,000, 1,100. They belong to counting numbers. Okay? Set of odd numbers. Are you familiar with odd numbers? Example, 1, 3, 5, 7, 9, 11, 101, 1023. These are examples of odd numbers. So all of them, if you are going to collect and gather them, they are example of set. Okay? Set of odd numbers. And we have also set of even numbers like 2, 4, 6, 8, 10, 12 through 200, 400. And we also have set of integers. Integers, we have negative and positive integers like -3, -2, -1. We have 0, +1, +2, +3. And set of prime numbers. Have you heard prime numbers before? I know that you have encountered this in when you were in elementary. Prime numbers. When we say prime numbers, these are numbers that has only one set of factors, and that is the number itself and number 1. Example, we have prime numbers from 1 to 12. We have 2, 3, 5, 7, 11. Why? These are the only numbers from 1 to 12 that are prime numbers, because these are the numbers which has only one set of factor. Like 2, you look at number 2. The only set of factor for number 2 itself and 1. Okay? Not the same with number 4, because number 4, it has 2 factors, because 2 times 2, okay, that is a factor of 4, and 1 times 4. So prime numbers are numbers that has only one set of factor. So if you would look at from 1 to 12, these are the numbers that are prime numbers from 1 to 12. So if we will have this, our set of prime numbers 2, 3, 5, 7, 11 under 1 to 12. We have also set of numbers greater than 7 but less than 15. So you would think of numbers that are greater than 7 but less than 15. We have 8, 9, 10, 11, 12, 13, 14. Okay? Why? Because 8 is greater than 7. 8 is greater than 7. 9 is greater than 7. 10 is greater than 7. 11 is greater than 7. 12 is greater than 7. 13 is greater than 7. 14 is greater than 7. But less than 15. Okay? So, these are example of set. We also use set in mathematics. Now, why is it we need to study set? Because the concept of set will give us clearer understanding in all branches of mathematics. When you go to algebra, you would always encounter set. Like set of equations, set of solutions. Like when you go to geometry, set of polygons, set of measurement, set of angles. So when you go to trigonometry, set of solutions. When you go to statistics, you would always use set. And that's the reason that we need to study the concept of set. So, by that, we will define set. So, set, a very common definition of set is a well-defined collection of objects. Okay, let's look at this example. Which of the following sets are well-defined? What do you mean by well-defined? Well-defined, it means that the element or the member of that set is definite and distinct. Example, which of the following sets are well-defined? So let's look at this. The set of all large numbers. Okay? Is it well-defined or not well-defined? It is not well-defined because my large number might not be your large number, right? Okay? Maybe my large number is just 100. Or maybe your large number would be 1,000 or 1 million. So it is not well-defined because the set that has been mentioned has no definite element. Okay? Has no definite element. Because maybe my large number is not your large number. Okay? So, the set of multiples of 5, is it well-defined? Yes, it is well-defined. The set of good writer, not well-defined because maybe your good writer is not good writer to me. Maybe my good writer is Jose Rizal, and maybe your good writer is Andres Bonifacio. Okay? So, the set of nice people in your class, it is also not well-defined. Why? Because maybe for you it is good, but for me it's not. Okay? So, the set of prime numbers from 1 to 100, is it well-defined? Yes, it is well-defined. Because the set of prime numbers from 1 to 100, it would always be the same to you and me. If I'll get all the prime numbers like 2, 3, 5, 7, 11, 13, if I'm going to list all of this, if I'm going to get all the prime numbers, you would come up also the same prime numbers. That's why it is well-defined. Okay? Next, the set of even numbers. Is it well-defined or not well-defined? Yes. Why? Because all the set numbers, all the set of even numbers to me is the same with all the set of even numbers with you. If you have 2, I have 2. If you have 4, I have 4. If you have 6, I have 6 also. Okay? We have the same set of even numbers. That's why it is well defined. The set of numbers greater than 7 but less than 15. Okay? Is it well defined or not well defined? Yes, well defined, because you can definitely point out all the greater than 7 and less than 15. Okay? If I'm going to list down all the numbers that are greater than 8 and but less than 15, if I'm going to list down 8, 9, 10, 11, 12, 13, 14, if those are the numbers that are greater than 7 and less than 15 to me, you would also have it as your answers. Okay? So therefore, that is a well-defined set. Next. So, set, we use capital letters to denote set. Example, A, B, C, D, and so on. So we use capital letter to denote set. Example, A, B, C, D, or set A, set B, set C, set E. And lowercase letter to denote the element of set, meaning the members of that set, it is represented by small letter. Okay? And we use braces to list the element of a set and to separate them by commas. Example, look at this. Set A is equal to, always remember this, that a set is enclosed by braces. Okay? So, example, set A is equal to 5 as the first element, 10 as the second element, and 5 as the first element, 10 as the second element, and 15 the third element, 20 as the fourth element. So these are we have set A, and the element of set A are 5, 10, 15, 20. Means that 5, 10, 15, 20 are the elements of set A. So, if you would see a symbol like this, okay, it is read as an element of. An element of. Example, 5 is an element of set A. 5 is an element of set A. Read as 5 is an element of A or set A. So example, which of the following sets are well defined? The first one, the set of all factors of 18. Is it well defined? Yes, it is well defined, because you can identify specifically all the factors of 18. Next one, the set of honest people. Well defined or not well defined? Yes, it is not well defined. Why? Because a certain person might be honest to me, but he or she might not be honest to you. Therefore, it is not well defined. My honest is not your honest maybe. Okay? Next, letter C, the set of senior citizen. Is it well defined? Yes, well defined. Why? As long as that person has the age of 65 above, he or she belongs to the senior citizen. Therefore, It is well defined because my senior citizen is also senior citizen to you. Next, uh, there are three ways in which we can describe a set. First one, the roster method or listing method, the verbal description method, the set builder notation. So let's start with the first one, the roster method or listing method. It is a method describing set by listing each element of the set inside the symbol braces. Okay? So now another thing that you have to remember in roster method, you will just list once every distinct element. We will look at that one in the example later. The order of the element does not matter. Okay? Does not matter the order. Now let's have this example. First example or set A, counting numbers from 1 to 4. So you are going to type all the counting numbers from 1 to 4. So that's why we have it here. We have it here. 1, the first element, second element, 2, third element, 3, 4. Now, set B are the letters composing the word Philippines. The letters composing the word Philippines. Now, based on our definition, you are just going to list once every distinct element. So, example, in the word Philippines, how many P in there? We have 3 P's in the word Philippines. Now, if you would use the roster method, you will just type the letter P once. So, look at this. We have the word Philippines, but when it is listed already, you will just have the elements are P, H, I. How many I in the word Philippines? L, N, E, S. Okay, you got that? Next, set C. The elements are 5, 10, 15. These are the numbers with the multiples of 5. Now, when you see this 3 dot, it means ellipsis, meaning there are elements that are not written in this place. Now, the last one, set D, we have moon, M-O-O-N. Now, you might ask me, sir, you said that distinct element, you will just list it once. But why is it there are 2 O's in this element? Now, let me tell you that in this set, we only have one element. And that is moon. Look at this. They are not separated by commas. Remember, every element is separated by comma. Therefore, moon in here is just one element. Okay? So that is the roster method or listing method. Next, we have the verbal description method. It is a method of describing set in words. It's very simple. So let's say, for example, we have this set A. So it is, if you are going to write set A, like 1, 2, 3, the elements of set A are 1, 2, 3, 4. So if you are going to use the verbal description, you will just simply write or say set A is the set of counting numbers less than 5. Set B. Set B is the set of letters in the word Philippines. So, we have that. And next, set C. We have 5, 10, 15, and so on. So, when you are going to write using the verbal description method, you will just write it or say set C is the set of positive multiples of 5. Now, what about for D? Set D. Set D is the set of a natural Earth satellite. So the next one, the set builder notation. It is a method that lists the rules that determine whether an object is an element of the set rather than the actual element. This is very simple. Let's take, for example, set A, set B, set C, set D. Example, set A. Okay? Set A is the set of all x such that x is a counting number less than 5. So what has been added here? It's very simple, just this one. So if you are going to compare this from the previous one, from the verbal description method, what has been added in here is just this one. So very simple. So next, we have set B. Set B is the set of all x such that x is a letter in the word Philippines. Next, set C. Set C is the set of all x such that x is a positive multiple of 5. Set D is set of all x such that x is a natural satellite of the Earth. Okay, so those are the three ways in describing set. Now, let's proceed to this one, empty set or null set. The symbol for an empty set or null set is just this one, like a capital O or 0 with a slash on it, or the two braces. Okay, a set with no element. So when we say empty set or null set, it is a set with no element. Example, set A is an empty set if set A looks like this. It means set A has no element. So which of the following sets are empty set or null set? Set A, is it empty set or null set? Yes, it is null set. What about this one? Is it null set? No, it's not. Why? Because there are elements under set A. Next, the next one, is it null set? Yes, it is null set. Okay, two sets that contain exactly the same number of elements are called equivalent set. Example number 1, set A and set B. Why is it they are equivalent set? Yes, because these two sets, set A and set B, they have the same number of elements. How many elements in set A? We have 1, 2, 3, 4. What about in B? How many elements in set B? 1, 2, 3, 4. Therefore, example number 1, set A and set B are equivalent set. Or you are going to write like this in symbol, in mathematical symbol. Okay, this one, look at this. Read as set A is equivalent to set B. Next example, set C and set D. All you need to do is you will just count all the elements under that set. So, how many elements under set C? 1, 2, 3, 4, 5. What about in set D? How many elements in there? 1, 2, 3, 4, 5. Therefore, set C is equivalent to set D. Next, equal set. Two sets that contain exactly the same elements are called equal set. Example number 1, set A and set B. Are they equal set? Yes or no? Yes. Why? Because if you would take a look on set A, the element of set A, we have 1, 2, 3, 4, 5, 6. What about in set B? We have 6, 3, 1, 2, 4, 5. Though they have the same elements? Yes. Therefore, set A and set B are equal set. So if you would write it in a mathematical symbol, so it look like this. Read as set A is equal to set B. Next, set C and set D. So all you need to do, if you are asked whether they are equal set, all you need to do is to take a look on every element of that set. If all elements in set C are present in set D and all the elements in set D are present in set C, therefore set C is equal to set D. Okay? So, look at this. If you are going to compare the two, equivalent set versus equal set, two sets that contain exactly the same number of elements are called equivalent set. For equal set, two sets that contain exactly the same elements are called equal set. So, what's the difference? Equivalent set, two sets having the same or contain exactly the same number of elements. But for equal set, contain exactly the same elements. Okay? So, these are the examples. Next, subsets. Set A is a subset of B, written as A subset of B, if and only if every element in A is also an element in B. Okay? So, it means if the elements in A, set A, are present in set B, therefore, set A is a subset of set B. So, let's have an example where A is a subset of B. Example number 1. Set A is a subset of set B? Yes, A is subset of set B because all the elements in set A are present in the elements of set B. Next example, A, a subset of, or set A is a subset of set B? No. Why? Because in the elements in set A, not all elements in set A are present in set B. Therefore, set A is not a subset of set B. What about this one? Letter C. Set A, which is an empty set. Set B, having the elements of M, A, T, H. Is A a subset of set B? Yes. Now, you might ask, why is it A is subset of B? When in fact, there is no element in set A. And there is no element that is present in set B. So, by definition actually, every empty set is a subset of every set. Okay? So, that's why set A, which is an empty set, is a subset of set B. Because every empty set is a subset of any set. Next, list all possible subset of a given set. Example, you have this set. So, you are asked to write all the possible subset of a given set. So, these are the subset. Empty set. It has been mentioned that every empty set or null set is a subset of any set. So, these are the possible subset of this set A. We have empty set, we have 1 or element 1 and element 2. And note everyone that every set is a subset of itself. That's why the fourth subset, we have 4 subsets in this set, and the fourth one is the set itself. Next, set B. Under set B, the elements are B, O, Y. Okay? So, what are the possible subsets under set B? Okay? Empty set, B, O, Y, B, O, B, Y, O, Y, and B, O, Y. Because this is included because every set is a subset of itself.